and the situation of plastic waste in this country, the types of plastic, the processing that is required for road construction, some methodologies, basic properties, advantages, disadvantages, and case studies. So first, we need to understand what exactly plastic is before we talk about plastic roads. So what are these properties in plastic that makes it a really good fit to be used along with bitumen in the road sector? So let's start with understanding plastic. It can be synthetic, it can be semi-synthetic, it can be in the form of a resinoid polymer. They are mostly having a very high molecular mass. That whether any other additive is present in plastic or not present in plastic, the most primary two components that are always going to be present is carbon and hydrogen. They're always going to be there. So they form a very different matrices of combinations and chains of molecules along with different. The most commonly used plastic are basically all industrial fabrication, coming out from industrial fabrication of petrochemical industry in India, that which we used. Apart from that, we have thermosetting plastic and thermoplastics. This is the range of plastics that we are going to when we talk about plastic waste first. So amongst this entire spectrum of plastic wastes, we have to select a few of those which easily disintegrated, which can be easily shredded, which share the chemical properties of the bitumen so that it can be mixed with bitumen in a better manner. Because if they are not on the same page with the properties of bitumen chemically, they might not blend well, and we really want them to blend well. Why we are interested in these plastics? The primary reason of calling a plastic is something that is having a high resilience, high resistance under any subjective pressure. So we want this kind of material, which is in the congregation with bitumen used for road construction. Also, what is something I would like to emphasize it more over here is that we are dealing with a lot of plastic waste issues, solid waste management, landfill management, plastic contributing to toxic leachate, all these things in the country and globally as well. Have pollution in our oceans due to plastic. We are having, and especially in right now we are going through this pandemic, even more generation of plastic waste is there. So we find out sustainable alternatives wherein we can combine the usage of these waste materials and also implement it in a way that the technology we are using for road construction can save some money by the use of this waste material, and at the same time we can save some pollution also. Before I start with what are the different modes of mixing and processing, we need to first understand what types of plastic do we have in existence right now around us as the industrial end use products. So we have PET, polyethylene terephthalate, which is commonly which we use in this water bottles of Bisleri and Aquafina and all this. And we have this cool drink bottles, we have sports drinks bottles. So all these bottles use the PET. Also, there are a lot of PET products used for storage. So like you have a lot of different boxes and different containers in your kitchen which are PET as well. Then you have polyethylene high density, which is HDPE, which is commonly used in milk and juice bottles, detergent bottles, shampoo bottles, grocery bags, cereal box liners, all these things. The most common, we have polyvinyl chloride. We have it in plumbing pipes, food packaging, which you usually offer from Zomato and Swiggy these days. Shrink wraps, which are used over, for the packaging processing only. And you have toys and all these other things. LDPE is another one, which is polyethylene low density. So this is used in our regular bags that we use for garbage disposal, or the bags that we buy our vegetables, or we take general grocery store, they give us a little polythene sort of bag. So this is the low density. This is one of the most harmful also, because all these are non-biodegradable, but this is also actually a finer low density plastic, you know, option, which eventually ends up choking our drains, or ends up, suffocating our animals and birds as well. So ecologically, if we look at it, this polyethylene low density is, not something that we would want scattered around and strewn across our garbage dump and landfills. Then you have polypropylene. It's used to make, yogurt containers, food containers, luggage and all these things. Polystyrene, you have disposable takeout styrofoam disposable utensils like cups, plates, all these things are using polystyrene. And then you have bisphenol A, which is basically used in CD, or the baby bottles, headlight lens, a little tougher format, a little difficult to shred, and at the same time way more non-biodegradable. And it takes around 50 years or more to decompose itself. 450 years in a timeline, you can just imagine how much time it stays stagnantly in the same format wherever it is disposed. And in this, you can see the plastic waste, data of some selected cities of India. Although this is collected by CSE, Center for Science and Environment, for 16 major cities. On the map, you can see a lot lesser, just to give a geographical variation of this. You can see the cities like Delhi, cities like Kolkata, cities like Ahmedabad, Gujarat, mein Surat. You can see Mumbai, and then you have Bangalore. Then you the major cities, the Hyderabad, the bigger cities, the metro cities of our country. You can see the plastic waste they're producing in tons per day is humongous. 400 tons per day. What do you call it? Faridabad. And then you have smaller cities like I'm sitting in Dehradun right now. So we have 14.66, which is way lesser than 400 something, tons per day. And Chandigarh, which is very close to Bhatinda, you can see 8.18, which is also lesser. So average plastic waste share in the entire solid waste scenario is 7% approximately. And we have around, 3.3 million metric tons per year as, plastic waste annually. So this is very huge amount of plastic to process, given that it is non-biodegradable, given that these disposable bottles are single use, they cannot be recycled. So that adds more complexity to the waste management of these plastics. So in India, we use, annually as a per capita plastic generation from each one of us is on an average of around 4 kg. But if you see others like Japan, US, Australia, they use plastic in as high quantities as around 46, 70 kgs per capita every year. So we can, if we compare, we can be a little bit relaxed for per capita generation, but at the same time, this is of very high magnitude. So there is nothing that we can sit back and not be concerned about this huge amount of plastic waste. This is created in our country, generated in our country, because 3.3 million metric tons per year, and growing, especially in the pandemic times, because now we have even more medical masks and new PPE kits and your shields and all these things adding up to the same menace. So one more thing, as a country, have decided to phase out the single-use plastic by July 2022. I'm very hopeful that all the companies and manufacturers are going to abide by the decision taken by the central government in this regard. So I've already told you about the different sort of non-biodegradable types of plastics that are causing issues by clogging the drains, and eventually causing flooding, choking the animals, and destroy the aesthetics of the towns as well. So this was all about what exactly we want to get rid from. We need to first understand the enemy. We need to first understand the problems that are created by this plastic. And then comes the evolution of the plastic road design in India. It was designed in, first patent was filed in 2001. It was by Professor Rajgopalan Vasudevan, who was a professor of chemistry at Rajar College of Engineering. Also, further, he was awarded the Padma Shri for making the first patent in this direction. He also later on made plastic coated stones, plastones, which also is another patent to his credit. So this was just the first thread of starting of research in this arena. 20 years from then, if we see 20 years from that point, if we see now, we have come a long way in the research of plastic roads. Currently in Bangalore Municipal Corporation alone, we have 600 kilometers of road paved with plastic roads. Similar in other parts of Karnataka, Chennai, very extensively used by NCR and Rajasthan also. And slowly the other states and other, state PWDs and even the central PWD is taking up the cause with various industrial involvement from bitumen-based product companies, companies which are producing additives, companies like Virgin, which are producing equipment for foam bitumen, also companies which are coming towards the mixed design segment of the industrial part. So these all are going to, result in a very extensive use of plastic roads in India. I'll come to that later on when we'll come to the case studies. So I'll explain 2 or 3 case studies, although we have many, but just to focus on understanding how it goes on. Also, I will discuss about what is the extent of use in India in the current situation. So what are the particular reasons to choose plastic for road construction? So in a nutshell, if I say without getting into the specific values and ranges of the parameters, in a nutshell, if I say we are using the hazardous, this construction is economical because we are not using any separate equipment. The road parameters which express the performance later on in the O&M stage, and also the durability, the wear and tear, the fatigue, the strength, the Marshall strength properties, the flow properties, the occurrence of stripping in bitumen and aggregates, the occurrence of potholes. All these, have been witnessing a great, improvement as far as over and above the conventional mixes are concerned. So this is economical. This is generating a sustainable technology wherein we are going from waste to, creating wealth for our country. And after doing all this, we are eventually also saving money. Also saving money, which, was into completely using bitumen. Now we are using replacement of bitumen by 6 to 7%. So we're using this waste, replacing the fresh bitumen, the virgin asphalt, by 6 to 7%. And at the same time, we are saving that money as well. So cost reduction per kilometer is also something that we should look forward to. So apart from this, other institute, which is, apart from Professor Vasudevan's research, we have CRRI, NHAI, MORTH, IRC, and the Indian Center for Plastic Environment, which have been, promoting the use of plastic roads in the country. So now let us start with the process of how it is done. How are we going to proceed with making these roads? So at the laboratory research level, a lot many projects have been going on. We here at DIT University have also conducted, one such research project, little UG project for our students. And they have came up with some primitive results. I'll share that with you as well. So the first part in the process, the segregation and separation from this waste. So let us see. You have to segregate all the different types of plastics based on the microns. Here, when we segregate, what we want for our road construction are those plastic which have a maximum thickness of 60 microns. These are the ones which we require. The ones which have a maximum thickness of more than 60 microns, we may not use them in the road construction because it's very difficult to shred them. So we are, focusing on these ones only. The second part is cleaning and drying. So you have to first clean it to make sure that you reduce any occurrence of dirt, any occurrence of other toxic materials or any chemicals which are deposited on the surface. So as the texture is, completely clean, and you need to make it in a, dried format. It needs to be dried after that. Drying is very important because if there is a lot of moisture in the plastic shreddings, they may not again blend well with the bitumen. So third part is shredding. So different types of plastic mixes are mixed together first, and then these different types are shredded using a shredder machine. I'll show that to you. So this is the type which can be used for shredding. Now you can see in this a little photograph on the right hand side how this shredded plastic looks like. Now it again has, a size, dimension, aspect ratio which is not uniform. So we can see, there are some particles which are micro, some particles which are very small, some particles which have maybe, a size a little bigger than the conventional required size. So now what is the required size? So we need something that can pass the 4.75 mm sieve and something that can get retained on the 2.36 mm sieve. So we all have, all highway engineers must, done the sieve analysis in the laboratories, so they know what I'm, saying. So the plastic waste, what is retained on 2.36 mm sieve, this is the plastic waste that we are going to use. Any other particles which are passing from 2.36 mm sieve, which we may not be interested in because they are extensively fine. And so this is how you first do the sieve analysis, and the final collection of this particular size and dimension based plastic is done in storage. Then there are two processes, dry and the wet. So in majority of the countries, and as far as the research evolution is also concerned, the dry process takes up the market share of around 95 to 98%. Very rarely people go with wet process. There are little applications involved in wet process, and the research is in the evolutionary stage. So the maximum research that has been done till now, the maximum ease of, execution of making these mixes is associated with the dry process. So what do they, what do they differ in? So I'll just explain the dry process first. So in dry process, what they do is they take this aggregate, they preheat the aggregate first. The preheating of aggregate is done. So the heated aggregates are taken up at 165 degrees Celsius. And once they are heated, they become hot aggregates now. So this is done separately. Now you mix the waste plastic that was retained on the 2.36 mm sieve, and now you get these aggregates which are poly-coated aggregates. So it again has to be done on a very controlled temperature. If you raise the temperature beyond 200, 210, then the plastics are going to melt. And they once they melt, they are not going to have any coating above these aggregates because their structure will receive the particular saturation point, and they will not be able to coat the aggregates better way. So we need to control this temperature. So only 165, 170, this is 150 to 170 degrees Celsius only is the range which will be used to mix them with the preheated aggregates and then the waste. So now once you have these poly-coated aggregates, the third step is you want them to mix with the bitumen. You want these aggregates, poly-coated aggregates, to mix with the bitumen now. So now you add hot bitumen at a similar temperature, maybe around 160, 170, 165, this range itself. Then you take this polymer bitumen aggregate mixture. This entire mixture contains the waste plastic, it contains the bitumen, it contains the aggregates. So all these three things are now combined into polymer bitumen aggregate mixture. And once you have this mixture ready, which will be around 150, 155 degrees Celsius after the mixing, you are supposed to take it to the site on the road. And by the time you will lay it down on the road as a pavement, it will come down to 130, 125. You need to wait till it comes down to even further down to 110 and 120 degrees Celsius, and then you lay it on the road. So for this, obviously, the plant in which you are manufacturing the polymer bitumen somewhere near about to your site only. It cannot be really far away, or else you should have intermediary arrangements to keep the entire mix heated up. So This was the entire process. So I think dry process must have been very clear now. We can take up queries later on once I finish with my. So now I'll come to wet process. So the little difference that the wet process has from dry processes, in wet process, you really don't go for, these preheated aggregates. What you do is you take the bitumen first, and then you add the polymer waste to the bitumen itself. And it is not in shredded form. Like shredded plastic from 2.36 to 4.75 mm. But in the wet process, you don't want to use these shreddings, because these shreddings are going to give unnecessary, higher viscosity, a difficulty in coating the aggregates, a very different, inconsistent, and non-uniform texture to the entire bitumen mix, which you don't want, because then it will not bond with the aggregates. So now, what should we do? So the other thing that they do in wet processes, that they convert it into a powdered format. So this way, it gets a little easier, and it maintains the texture and the viscosity of the bitumen. So this is what we do. So I think, Priya, is it going well? The audible thing is going well?
Yes, yes, ma'am. It's going well.
Okay, thank you. So just checking, I thought people are sleeping somewhere. It's the afternoon time. You all have had lunch. Must be getting a little. So, okay, let's continue. So now, when we continue with the format of plastic shreddings combined with the bitumen, and further, now we add the aggregates. Obviously, the aggregates have to be, in temperature level for the mixing. So now the bitumen is not going to coat on aggregates and then get mixed with plastic. It's the other way around. So in this process, there is a little, little difficulty in maintaining the texture and viscosity of the bitumen. And very specially, the rheological research part in determining and controlling the rheological parameters of the bitumen, they require a little more evaluation. They require a little more evolution and evaluation both, to be implemented on a large scale. Besides this, this process will also require specific, specially designed equipment, which will add to the costs. So this is why, wet process is not used too frequently. However, with time, I'm sure once they figure out a way to match the, outcomes of dry process, they'll be using it more often. Again, in the wet process as well, they, lay it at around 120 degrees Celsius. So this is a mini hot mix plant wherein you preheat the aggregates for the dry process, and those preheated aggregates are further, mixed with the plastic waste, as you can see in the photograph on the right. So now they are having, the crusher is rolling out the hot aggregates, and on the side you are putting out waste shredded mix. So they have a certain specific set range of percentage in which you add these things. You cannot add them too much in abundance. So once you're creating the poly coated aggregate, then they may be in the ratio of 50-50. Further, if you're mixing it in a powdered format in bitumen, then it's another different, ratio. So once you do this, then bitumen is added with the coated aggregate. Now you see that, in the plastic coated aggregate in a sump, now they have added the liquid, molten bitumen, and it needs to be really mixed well. It can be done mechanically for smaller quantity. However, if it is to be done on a larger scale, then you need proper mixers and proper equipment for that. And then you can lay it on the road, as you can see with the paver they're doing. So in India, we have already implemented this at many stretches in plains, many stretches in the Deccan India, many stretches in the North Central India, and as well many stretches in the Himalayan ranges as well. So the performance in the colder regions have been, really, really nice. So there is IRC special publication 98. It was rolled out in 2013, which was about 12 years after Professor Rajagopalan's research. And this IRC code is 24 pages only. It's not a very hefty and extensive code. Basically, it covers the dry process only. It's not covering the wet process. And it is covering almost all the details that I have shared with you right now. The processes are same, and the dry process is same. And at the same time, the temperature ranges of various mixtures and all these, they are almost all the same. So there is a little, requirement which has been specified in this IRC code. So what I have done is I've taken the table as it is, so that you are familiar with, all the parameters that have been listed down. Given a minimum stability of 12 in the Marshall and minimum flow, and the Marshall quotient as 2.5 to 5. Now, in usual, design mixes, when you create a laboratory, you give these blows to the sample on both faces of the specimen. So they have made it 75 blows to make sure the sample is adequately compacted. Percent air voids are between 3 to 5%. It may range. It may range based on a lot of parameters. It may range based on a lot of texture based properties of this mix. It may range on the base of how well the polycoated aggregates have taken over, and how well the aggregates as well as the blendings were, interacting, and were not having a lot of dust involved within them. So retained stability at 98%, ITS, indirect tensile strength around 0.9, voids in mineral aggregates, voids filled with bitumen. All these values are specified as the, minimum requirements for modified dense grade bitumen pavement layers. They have a different set of requirements for OGFC, open graded, but mostly we are, going with dense graded in India in the conventional mixed designs. So we'll go by, these basic requirements. And 6 to 8 is the percentage of replacement of bitumen, depending on low rainfall or high rainfall. So the rainfall, so if you're doing it in an area like Assam, maybe, or maybe an area like, in the Himalayan ranges, cities, they have the freeze and thaw action with the snowfall. So higher rainfall, higher snowfall, areas in which you have a higher freeze and thaw action, say like Leh, Ladakh areas where you have border roads, so therein you need more quantity of bitumen replaced with this plastic waste. So instead of going with the lowest possible 6%, you may take it to a little higher and above till 7% also you can try in your laboratory. And based on the kind of results you achieve, because it will also depend on also depend on the aggregate properties, how well it is blending, the type of additives, if you are or you are not using the additives. So if you, combine, then you may be able to iterate and come to a really consistently performing adequate sort of mix. Once you have that design, it's ready for implementation. So this is all about, the dry process. In wet process, as I've already told, you need a mechanical stirrer because the powder is involved, consistency of the texture, and you need stabilizers that adds to the cost. You again need, stabilizers to make sure that it is cooling down properly, because the major problem is viscosity. It will be at a very high viscosity when you try to mix it, and you have to really make sure that the mix is consistent. So it require investments, and that is why we really don't use this as an economic alternative to sustainable, plastic road construction. So then you have these, properties. Comparing the properties between conventional and mixed designs. These conventional mixed designs, when I say, it's mostly DBM, dense, bituminous macadam and bituminous concrete. So then you have these Marshall stability, binding properties, softening point, penetration value, rutting, stripping in potholes of roads, seepage of water. So you can compare it with the conventional and the plastic roads. This is a very general basic comparison, and it can be more specific when it is comparing a certain design mix as the control and a certain design mix as the plastic mix as well. I'll show you some research that we have done in our lab later on. What is most striking over here is, if you can see the rutting performance in the conventional mixes go up to like 4 to 5 mm, 6 mm, as well as, as high as 7 to 8 mm as well. But with the plastic roads, the rutting comes down to lesser than 2 mm or even 1.5 mm, and sometimes not even, you won't even see any sort of rutting even after multiple cycles of use. And even this performance is retained even in the higher traffic zones. So on rural highways also, it is very beneficial to use plastic roads, because when you're using a lot of other types of design mix, they have a constraint of heavy traffic movement and how it takes the axle loads. In the case of plastic roads, they are performing exceptionally good in terms of rutting, and the adhesion between bitumen and the waste and the aggregate is such that stripping is also negligible. In the stretches in which they have laid, performance assessment was done by CRRI and CPCB, and I'll discuss all those in the coming slides. And so when they did this assessment of performance in the ONS, there was no instance of stripping and minimalistic potholes. That eventually adds to the durability, and that also reflects how it is taking care of the strength that is required for a pavement to sustain, and also reflects very good fatigue resilience. So the seepage of water is minimum. Obviously, when the seepage is minimum, the stripping is also going to be negligible. So these are some properties which give us a insight and a window of and we can understand that how these mixes are not only sustainable, are not only waste to wealth, are not only economical, but are actually improving upon the performance of the pavement, right? So now I'll again share. These are the results. These are not, results from DIT. These are the results from Professor Rajagopalan, cost analysis, cost analysis regarding, the stretch that he calculated it on. So he took it on a 1 kilometer stretch of, 3.5 width, standard width that we take. And he added a lot of different costs for plain bitumen and plastic bitumen. The construction cost alone is going to show you a difference of around 2 point something lakhs. Then the maintenance cost and the renewal cost, which you need for overlays and regular maintenance, patchwork and all. So then your total cost of minimum service for 5 years is calculated. And so overall, if they come to then it's around rupees 6.3 lakhs is what you save in cost per kilometer of road length in these roads. Obviously, this data implies more to the higher end highway constructions made for higher axle movements. As you go towards a little inferior distances, which are being used on, the major district roads or other roads. So therein also you can see, if you go by the minimum standards of it at all as well, therein also you save around 50,000 to 1 lakh 2 lakh rupees per kilometer, even in the inferior mixes. So this is again a very good indicator of performance coupled with economical performance as well, economical feasibility. Then there is this interesting document by Plastic Waste Management. It is given by Ministry of Housing and Urban Affairs. Why I'm showing it over here. It talks about plastic waste management. So we as civil engineers, as highway engineers, we know the aggregate properties, we know the bitumen properties, we know the advanced tests that need to be done to make sure mix is evaluated properly. We know all the tests that are to be done on a stretch of road after 5 years, 10 years, like Bankelman or falling weight deflectometer or lightweight deflectometer or your distress surveys. All these things we are, very much familiar with. But herein comes a new compound, a new molecule, which is plastic. And it is very important to understand the properties of these different types of plastics, the types we discussed in the initial 2, 3 slides. So they have their own thermal resiliences, they have their own, melting points, their softening points, and variety and different types of mixes of these plastic shreddings that are coming to combine with your bitumen in your mix design, they are going to change a lot of your bitumen as well, because their chemical composition is going to be a little different. So this handbook can be used to understand all these behavioral properties and chemical compositions of different types of plastics. Interestingly, they have covered an entire chapter in this, and they have referred it to use of these plastics in their different types with their different properties in context of road construction. So they've made our work really easier. So we need to understand not only these properties of plastics before we try to experiment with these. This document is available on the internet, and if you wish, I can share it with you as well. Then there was another study conducted by CPCB, in which they did a certain streets in Chennai, and they calculated the post performance parameters of plastic waste. So once they have already laid down the roads, after around 5 years, they did the post performance surveys. So the years in which they were laid were 2002, 2003, between the first of the century and first decade. And then they tried to know the roughness, the skid resistance of the tires, the sand texture, the field density, and the BBD deflections. So if you can see at the BBD deflections alone, the deflections are not very high. The performance of the road after 5 years of use is pretty good. And at the skid numbers, which are also pretty much lesser than 65, which is good. And if you see at the roughness indexes, again, it's indicating a good tolerance value. So there are some indicators of the post performance. Now moving on to some other case studies also. So yes, we also save 3 tons of carbon dioxide for every kilometer of road, because when we are using these plastics, we eventually protect these plastics from getting incinerated, which would have produced that amount of CO2 in the atmosphere. So as I told you earlier, in the base minimum configuration of the design mix also, you are going to save around 50,000 rupees to rupees 1 lakhs per kilometer stretch of road. Also, one another added benefit is they use a huge quantity of plastic for a short stretch of road. So eventually, when you make a 1 kilometer stretch of road, you end up using a great quantity, which adds to the waste consumption and utilization. So let us see these ductility, penetration, and softening point values of percentages when introduced inside the bitumen modified modification. So as you can see, we have added 1%, 2%, 3%, 5%, and just to be on the, we will never go beyond 8% in the replacement, but this 10% is just for the understanding of the behavior of ductility in bitumen. So in centimeters, see the ductility is reducing, the penetration value is also reducing, which the softening point is increasing. So why this softening point is increasing? Because the plastics have a very high softening point. They are ranging in softening points. I'll show you in another slide also I have. Yes, you can see here in the so the plastics have very high thermal resilience, and their softening points ranges from 100 to 160, 160 degrees Celsius, which is too high. So, and our bitumen softening points in our VG30 or 60-70 penetration grade or 80-90, 80-100 penetration grade, they are not as high as the ones of the plastic. So when they create the more percentage of plastic you'll keep on adding, the more the softening point temperature is going to be there. So again, if you see strength and the bending strength of these aggregates, which are coated with plastic, the more percentage of plastic coating is present in these aggregates up till a ceiling of the compressive strength and the bending strength values are also showing a good increase. So the combination of these two, the plastic coated aggregates, are good as far as the performance indicators are showing. Then you can see the aggregate impact value. It reduces the moment you increase the percentage of plastic from 1% to 2%. So the impact value is also showing a great improvement. Then you have Los Angeles abrasion. Again, the abrasion is lesser for those particular mixes which have more percentage of plastic. Even when you did the soundness test, they did not show any weight loss. So the quality of aggregate greatly improved when these plastics were added. There are, these, I've already discussed about all these advantages and disadvantages. Just to give a little revision on them. So we are increasing the impact value, decreasing the abrasion, enjoying a more higher fatigue resilience, great wear and tear performance, lesser use of uh, virgin asphalt or bitumen, and a lot of reduced penetration inductivity, higher softening point, very less strutting, very less stripping and pothole emergence on the softwares, this on this pavements, and increasing the strength of the road because these aggregates have an increased strength and compressive strength performance. So very specially I would like to point out the major advantages in areas which are prone to snowfall and highly humid conditions, because the humidity reduces and the stripping reduces. So the performance of the road is way better than the conventional mix. But at the same time, it's not, um, it's not a all good situation. It has some drawbacks as well. One of the major drawbacks is when you heat these plastics, they combine with the inherent structure of their molecule, and they produce gases like noxious HCl, which is not desired in the atmosphere sometimes. So we need to control the temperature really nicely. That is why they have kept a range of 150 to 170 degrees Celsius. The moment you go beyond 170, 180, and 210 something, then these noxicity increases and the fumes are not good. So the cleaning process is very difficult, given the nature of plastic waste. And if you clean it prior, then in the storage they may start, releasing the chemicals, and the leachating will start. And so the another thing is that when you lay the road, just the first rainfall that you achieve, that you see or observe after the first, laying of the road. In those first rains, the plastics are going to release, certain chemicals, and the inherency loss will cause a little stick there, which may cause a mechanical abrasion on the surface, which is not desired, right? So this is something that is not desired. Then you have some additives in plastic, which, if left airborne or completely exposed to the top surface, uh, if those particular things were there inside, the additives were there inside the plastic, then again they might cause little threat to the environment. So what MORTH has done in this regard, they have recently in 2019 revised the IRC code, and it's going to be available to us very soon, the new code. So they have listed down several specific plastic types which these additives are found, and they have banned the use of those plastic types in these pavements. So this is the way we are evolving day by day in the research part of plastic roads. So there are three case studies. I'll just discuss them quickly, and then we'll move on to wrap. Yes, recycled asphalt pavement. So this was one example. This was made in Nagothane township in Maharashtra. It was made by Reliance Infrastructures, and they used 50 tons of plastic waste, which was taken from their surrounding areas. They basically used polythene plastic bags and garbage bags and the cling films and the flexible plastic products from their area. And they began the construction in 2019. It was completed in 2 months. And in the time that preceded that, it was a lot of rainfall in that area, 2,500 rainfall. And the roads were submerged in water for a long time. And usually after the water percolates down from the road in the rainfall season, we see that a lot of smaller stripping zones and a lot of small as well as big potholes arise, and patchwork is needed. Nothing of that sort was observed after the standing water came off from the surface, which was great. So they have very heavy traffic usage of this particular stretch, and so they calculated their costs, since it's not a national highway, it's a township based road. So the design mix must have been way inferior than the one which we used for the national highways. So for their calculations, they saved rupees 1 lakh of cost per kilometer, which is good, which is also good. 6.3 was higher, but even if you save rupees 1 lakh per kilometer is really good. Then you have another stretch made by CRRI. Again, this was made in 2019 by the Flexible Pavement Department of CRRI, Professor Satish Chandra and senior scientist Ambika Behel. They were a part of this project. So this was the laying that happened in this road above Shimla in 2019. And this is the current condition in the first week of January. The photographs, the current conditions were taken just a week ago. So you can see after 3 cycles of snowfall, there seems to be no significant damage to the texture. There is no, visible visual distress on this road surface, which is an again indicator of very good performance, especially in these zones where snowfall was higher. Then there was a bunch of students in my college, DI University, with our senior professor and me as well on the board. We did a little shredding of plastic spoons and disposable plates, and we tried to use this plastic waste bottle, waste spoons, and we shredded this and used in these design mixes. And we tried to do a little basic testing to find out the Marshall based parameters. We could see the stability of all binder content. If you can see, the stability is higher for 6% bit content, which again brings it is in accordance with the studies that have been done earlier, 6 to 8%. Further, we did the flow parameter testing and the voids in aggregates and voids filled with bitumens, and all of these we could see the performance of the 6%. So we finalized that optimum binder could be 6%. And if we really after adding the waste plastic to the mix, then you can raise it to 7%. So this is the stability for binder content only. And then when you see at the flow, and then when you see at the voids filled with bitumen, so 7% it's good to go. So this is what the evolution of bituminous concrete design mix was done in our laboratory. Then, as far as the country overall is concerned, in Chennai, we have Tamil Nadu, we have 1,000 kilometers of roads constructed by plastic roads. In Bangalore, we have 1,000 kilometer roads constructed now. Earlier, only in the urban territory of Bangalore, it is 600 kilometers. And including the nearby districts, it's 2,000 kilometers, which is a good number. Then you also have a rural roads program. As I told you, that these can take really good traffic, really high axle loads. So rural road programs, can take kilometers of plastic roads have already been constructed in the rural road PMGS5, which is Pradhan Mantri Gram Sadak Yojana. This was a program launched in the early part of this century by Pradhan Mantri Shri Atal Bihari Vajpayee. And it's one of the flagship programs of the infrastructure building in the country, and going very well, and already has been completed in several phases. They have connected so many towns and so many small villages. So even in rural roads, they have now implemented in 13,000 kilometers, which is great. So NHAI and IDCL, it's a subsidiary of NHAI. They are doing great work. So all these are, the things. I have a little small video to watch. Should I play it, Priya?